Hi and welcome to Royal Tutorials. I'm Kelsey and this is the chain rule. So the chain rule is basically a rule that allows us to take the derivative of a composite function. So here in green, this is the definition of the chain rule, and our composite function is f of g of x, where f of x is the outer function and g of x is the inner function. So when we differentiate this, we get the derivative of the outer function, so f prime, of g of x, or of the inner function, and we multiply by the derivative of the inner function, so times g prime of x. So to look at an example of this, let's start with 3 times sine of x squared, or sine squared of x. So to differentiate this, I'm just going to use an arrow to show differentiation. We can ignore our coefficient. We'll just leave it tagged on in the beginning, in the front of everything else, and we won't worry about that quite yet. So our first step in the chain rule is to take the derivative of the outer function, so f prime. So our outer function here is this exponent, of 2. So our sine of x squared, the squared part is the outer function. So we take the derivative of the outer function, so we get 2 and then times our inner function, g of x, so sine of x, and then whenever we take the derivative of an exponent, we lower it by 1, so we subtract 1 and we get 1. And then, so now we have f prime of g of x, but we still need our g prime of x. So that's the derivative of the inner function. And our inner function here is sine of x, because we calculate that first when calculating a value of this composite function. So the derivative of sine of x is positive cosine x, and that is our derivative. We can simplify that. So 3 times 2 we have 6, and then sine of x to the first is just sine of x, and then we multiply by our cosine x. Sorry, it's hard to have good handwriting with this writing program. So yeah, there's our finished product. And I can do a couple more examples. Let's try natural log of x cubed plus 2. That's a 3. Plus 2. Okay. So to differentiate this, we use our same chain rule method. So we're going to have the derivative of the outer function of the inner function times the derivative of the inner function. So our outer function here, as you might guess, it's natural log, the ln here, because we would calculate the inner before the outer when finding a value for this composite function. So the derivative of ln, our outer function, is 1 over our x cubed plus 2. So that's our f prime of g of x. And now we need to multiply by g prime of x. So our g function, our inner function, is x cubed plus 2. So the derivative of that we're going to multiply by is 3x squared. Yeah, just 3x squared. Because when we have a constant and we differentiate, it disappears. It equals 0. So here's our differentiation of ln of x cubed plus 2, we get 3x squared over x cubed plus 2. Oh, that was a crazy addition sign. Okay, if this is still confusing, or if this looks confusing, you can always take the x's out of it, and it helps to just look at f prime g times g prime. But let's try one more example. That should be helpful. Okay, so we can do sine of x squared. So I'll write it like this at first. Here's our sine of x squared. So to differentiate this, we take the derivative of the outer. This is probably getting a little bit easier and maybe a little bit boring now. The derivative of the outer, so our f prime, our outer function is our sine. So the derivative of sine is positive cosine. And we're going to keep our x squared there because we're doing f prime of g of x, and our g of x is x squared. That stays as x squared. And we're going to multiply by g prime of x, so the derivative of the inner function, and the inner function here is x squared, so the derivative of x squared, yeah, that's 2x. So that's that. We get 2x cosine x squared. You can get rid of those parentheses of the x squared if you want, but you don't have to, they can be there. So yeah, that was the chain rule. Let me know if you have any questions, and thanks for watching, and I hope that was helpful.